Hey everyone, it's Bob Crossan, Senior Managing Editor for Water and Waste Digest, and today I have with me Greg Senecal. He's the Director of Environmental Services for Labella Associates. We also have Keith Garbrick. He is the Southeast Regional Vice President for Labella Associates, and Ed Flynn. He is the Director of Planning for Labella Associates, and we're going to be talking about the Bipartisan Infrastructure Law as it relates to PFAS, the impacts this funding will have, and any regulatory steps that are kind of necessary to address PFAS in both water and wastewater. So thank you all for being here today. I really appreciate you guys taking the time.
Well, thank you, Bob.
Yeah,
Thanks for having us.
Yeah, it's great to have you guys and to learn a little bit more about this. Obviously, PFAS, an enormous topic area. The bipartisan infrastructure law, another enormous topic area. But how they combine into something more unique is kind of what we wanted to talk about today. So, but I wanted to start first. Let's start with some basics. What is in the bipartisan infrastructure bill that is tied to PFAS? Let's start with that so that we have kind of a foundation for our conversation today.
Sure. Well, that's something I can talk about. So the Bipartisan Infrastructure Law, which is also known as the Infrastructure Investment and Jobs Act, will provide up to $50 billion to address water and sewer infrastructure issues. Mm-hmm. And of that, around $10 billion will be focused on PFAS and contamination issues in water and sewer systems. So that's just the start, and it's going to be over a 5-year period. And of course, there's other funding that can be applied to addressing PFAS issues as well.
Yeah, and that's kind of the other thing I wanted to touch on too here. Obviously, one of the things I wanted to bring up, and I meant to mention this before even asking you a question, was that the US EPA did recently announce this type of action plan that has 29 PFAS in it, plus lithium, and the direction that they're hoping to take things and looking to have a regulation sometime by 2023. But in terms of funding programs, I did want to ask, like, are there current funding programs that do exist to kind of help with this? Because I know a lot of states are handling this on a state-by-state basis right now, and addressing it, especially in the Northeast when you're talking about New York and whatnot. So what types of funding programs do exist currently that are being tapped by utilities to address PFAS?
Yeah, well, there's multiple funding sources that are available for addressing any kind of public health issue, PFAS being one of them. So we talked about the Bipartisan Infrastructure Law, and that's one obviously source that's coming out, and will be coming out through EPA and then through the different state drinking water and state revolving loan fund programs. Mm-hmm. But currently, right now, a lot of communities and a lot of counties are looking to apply some of their American Rescue Plan Act money, and so part of the American Rescue Plan Act money, every municipality, every county in the nation got funding for that. They can use a portion of that for water and sewer infrastructure improvements through the State Revolving Loan Fund program. And with that, they can address public health issues. So one of them is PFAS. A lot of those go through municipalities. Some of those have gone through counties, and then they give the money to the water and sewer authorities for municipalities that don't have a water and sewer system. So that's one source. Another source of funding, and it always has been a source of funding for any kind of public health issue, is the Community Development Block Grant Program. Different states have different allocations, and they have different priorities. But generally speaking, anything that addresses public health issues like PFAS would be something that would be covered by the Community Development Block Program. And then for rural municipalities, which is a lot of communities that we deal with, they can use the funding. The USDA, U.S. Department of Agriculture, water and sewer funding has always been used again to address public health issues in rural communities. So, with all of those different sources, there definitely are some opportunities to assist communities to advance, cleaning up their issues with PFAS, both in the water system and in the sewer systems.
Yeah. Well, and also just trying to get ahead. I mean, like I had mentioned, the certain states are already trying to address this specifically, but from a utility standpoint, you could be looking at this down the road and being like, hey, we should probably start looking at how we want to pull from different funding sources to address this, knowing that a regulation is going to be coming down the pike in a couple of years. And speaking of that, what regulars? Let's go on to that regulatory side of things. What other regulatory steps that you guys see are necessary for addressing PFAS in both water and wastewater in the United States?
Um, I'll take a shot at that one, Bob. So, we are consulting engineers, and we advise municipalities. Um, as our firm is headquartered in the Eastern United States, and we've been working on PFAS issues in some northeastern states, including New York, for the last 10 years. So the way I guess I'd like to answer that question is from a regulatory standpoint, what the US EPA is doing with their three-pronged roadmap, which governs the EPA actions for PFAS for 2021 to 2023, I think is a really good way to go about it. And the reason being that certain states in the Northeast and the West Coast primarily have already begun to do research and regulate PFAS. And so we're currently looking, some states may regulate 10 PFAS, some may regulate 20. There are lists out there from the EPA right now of 21, 29 different compounds. PFAS are a very, very large family of perfluoroalkyl compounds. There are estimates of between 6,000 to 10,000 different compounds worldwide, and thousands of which are in use in the United States. So I think the right way to regulate it, and this may not be really well received by treatment plant operators, but I do think it's the way to go. Is the way the EPA has laid it out. The first prong of the US EPA roadmap is to conduct additional research in regard to human exposure for PFAS. And that includes research on, 6,000 to 10,000 different chemicals, trying to understand the actual toxicological effects on human health of these chemicals. And then the next step is to reduce the exposure. So first understand the toxicology, then write some hopefully common sense regulations, in the form of national drinking water standards under the Safe Drinking Water Act, to bring all the states, all the laboratories, all the consultants, and the methodologies too. One methodology to treat a small group of 10 PFAS may not match up well to a different group of 30, but sort of provide a national and a federal understanding of the toxicological effects, and then begin from there. And that's what the EPA has proposed. At the same time, to have, obviously zero exposure to PFAS would be wonderful. But they've been in manufacture and in use across the world, including the US, for 50, 60, 80 years now. So getting to zero is probably not really achievable, or not cost effectively achievable. So I think the way the EPA is starting out to really base it on science, do some toxicological studies, and then the roadmap is three parts: research, restrict, and remediate. But to do the research first, then write the regulations which restrict, and then remediate later, seems to be a good way to go.
Yeah, and given what we've seen so far with like the lead and copper rule and how they took in some additional public comment last year, I imagine there's going to be a lot of communication with industry leaders, with industry associations, and the scientific community on what even is achievable here. Because I know one of the challenges that people have heard is this concept of throwing around the idea of a part per quadrillion on this, which would be crazy. Such a small amount to be detected and to treat to. So I know that there's a lot of concerns from the scientific community on that part as well. But moving into more like kind of combining these two things, these funding opportunities and the PFAS regulations, combining those two things together, how do you see those kind of meshing and influencing or impacting the way that PFAS treatment technologies are going to be adopted in the coming years?
How about if I take a shot and then I'll hand it over to Keith. As you alluded to, Bob, that, in the research aspect of the EPA roadmap that came out in October of 21, right now there are really only two scalable, viable solutions to treat PFAS in drinking water and wastewater. And those are granular activated carbon, GAC, and ion exchange resins. Both have some ups and downs and limitations and whatnot. There's a lot of other research, bench scale research that's being done, as you mentioned, lower than part per trillion thresholds, and whether those solutions can be scalable and economically practicable, and where the benefits begin to diminish off needs to be determined. But for municipal water system owners, the technology that we have available, the funding sources that are coming out, it's going to take some getting up to speed, and getting up to speed may not be real pleasant. But at least it is, being researched at a federal level, and that isn't going to make anyone feel any better when they've got to do a $10 million water treatment plant upgrade in quick order. But as you suggested earlier, and I think Ed would chime in, and Keith will too, for municipal and local government leaders to begin getting ready, analyze where your potable water is coming from. Chances are, you can begin to plan for it. Build your capital improvement plans, get your capital improvement plans geared up and ready. Know for a fact that the groupings and listings of PFAS are probably going to get larger. They're not going to remain at 21, 29, or 40 specific compounds. They will be grouped together. And it's a really tough question, and I don't envy any municipal managers to think of, how when do we begin to test? Because when you test, you are then in a very time sensitive, health related situation. So I would suggest do a lot of research first. Before you test, get your capital improvement plans. If your community is relying on aquifer groundwater as a potable water source, if your wastewater treatment plant services any number of industries associated with textile manufacture, metals manufacturing, things of that nature, and you have municipally owned landfills that feed into your system, be ready for it, because you will have to treat it. And I probably didn't do a great job answering that. So hopefully Keith Ed circle me back.
You did, Greg. And I think just to add to that, all of the municipalities and all of the wastewater and water plant operators should start to get together their preliminary engineering reports to make sure that they're primed for the funding that will come out. Those communities that are prepared are going to be more competitive when it comes to the funding. Some of the funding will have some set asides for the testing that Greg was talking about. So there'll be funding for that as well. And then just making sure that the community recognizes it. And so when it gets to the town council or the village board, that they know it's an issue, that they know it's a priority, that they need to apply for the funding. And so I think just getting ready so you're competitive is very important for any kind of funding program.
Yeah, and I'll add to Greg's comments that, the good news is we have technologies now that treat this, that can, solve the issue. What we hope is with the funding that's available, the scientific community, the operators, we can come together and try to refine those technologies to where we become as efficient as possible about removing them from the drinking water and ultimately from wastewater. So, that's the positive thing. But, on the other end of the spectrum, these are going to be capital intensive projects. And so that's where, the planning like Ed and Greg are talking about are critical. but there again, there's not it's not all doom and gloom. We have ways that we can achieve the success that we need to in drinking water and removing these from the from the public and eliminating it as a health concern.
Hmm. Yeah. So last question here was how you think all of this will impact municipal operators and plant managers. I mean, regulations always add another burden, right? But what I mean, on that note, talking about the operators and plant managers, but also like how does it impact your work as well as consulting engineers and what you think it'll do for engineering firms as well. I think that this is such a big topic area, and I think there's a lot of little it's multifaceted, but curious what your thoughts are in terms of the impact, especially on the at the plant level.
Sure. How about if I take the the potable water treatment, and then I'll pump the wastewater treatment to Keith.
Okay.
Bob, you led into it perfectly. Being an East Coast firm that is headquartered in New York, we've been dealing with PFAS for about 10 years. And we've worked with a number of municipalities to treat their potable water for PFAS. So we're eager to spread our experience that we've gained to anyone we can. How it, and again, a lot of it is planning. If municipalities and potable water treatment systems, if you're planning and looking at an upgrade, plan some extra space. Plan a lot of extra capacity. If you're planning new municipal well fields, experiment, have backup well fields, have 1 or 2 backup plans ready for when you start testing. Some of the municipalities that we've worked with, and again, once you test and once you have laboratory data that indicates that you have PFAS in your water source, you have to communicate very quickly, very effectively, and very transparently to the public and deal with it in as quickly as you possibly can. Oftentimes here in the Northeast, in the time frame between discovering PFAS in the water source and getting a treatment system up and running, you're installing point of entry treatment filtration, for homes, or you're supplying bottled water for some amount of time. So the more, and again, it all goes back to planning, getting ready, getting your capital plan lined up to take advantage of it, and just being ready to act quickly. We have been able, for medium-sized communities, 20 to 50,000 people, add in granular activated carbon treatment systems within 4 to 6 months of discovery. But that may be very, very quick and fast. To do it right, you need to have planned and figured out a location for your add-on system to tie into your existing system. And although it seems very quick as a reaction time, and we're proud of that reaction time, that 4 to 6 months is I don't envy any municipal leaders during that time. Communicating to the public, providing alternative sources to drinking water, the communication that goes along with proving that point of entry treatment system units work. So again, it's a lot of planning. For engineering firms, it's a great way for the environmental disciplines to coordinate and work hand in hand with civil and municipal engineers, to find solutions for their common client and the communities that we all live and work in.
Yeah. And Keith, you want to talk a little bit about it from that wastewater angle that he had mentioned?
Sure. So obviously we anticipate and know that these regulations are going to hit drinking water before the wastewater side, just from the immediate impact to the health concerns. But the technologies are going to be similar to implement. So whether we're using them as a polishing method at the end of the treatment process on a large scale wastewater plant, or if we're going to target industrial users, if we can identify those and maybe put in a stronger pretreatment program for those industrial source users. that's yet to be determined. We think that's going to be, much further down the road, but something that needs to be in the mind of operators as well as municipalities, as that this could be coming as well. So while Greg mentioned a lot of the potable water side, one thing I wanted to mention too is that the technologies that are out there solve multiple concerns for municipalities, not just PFAS. So if you take an ion exchange, they're helping with disinfection byproducts there. So there's a lot, the technology may help them accomplish an overall higher level of quality in their water than they were previously used to. So again, a lot of benefits to what's out there. So but the wastewater side is still yet to be determined.
Yeah. Well, yeah, you make a good point that like putting ion exchange or granular activated carbon in your plant isn't just for PFAS. It handles so many other things as well. So
Right.
you are getting bang for your buck because of its swath of things that it can filter and treat. So anyway, thank you guys so much for talking today. I really appreciate your time today. And for everyone who's watching, we'll put some resources down in the video description below. I'm sure that Craig, Keith, and Ed all have things that they could link to. So we'll make sure to get those links for you down there. So check those out. And once again, to all of you guys, thank you so much for being here. We really appreciate your time.
Thank you, Bob.
Yeah, thank you for having us, Bob.
Thanks for the opportunity.